Now let us start what is vector. So see, vectors are represented with a bold or arrow bars. In the textbook, you can see vectors are having a bold letter. It can be a capital letter or small letter, it is okay. Above this, you can have A, it is called as a bar, or you can have B as an arrow, or you can also call this as a bar, or it can have a dark bold letter for that. So these three are used to represent a vector. That means it is having magnitude as well as it is having some direction. Next is absolute magnitude of vector. That means only if you are talking about magnitude, so it is represented by either this letter A, or we can use this is mode of A, mode of A. These two lines are known as mode, or you can have mode with the bar symbol also that can be utilized. With the bar symbol also that is can be utilized. The next, if you talk about geometrically, vector is represented by a line with an arrow. It is represented, you can see here on the top portion, it is represented by a line, a straight line with some arrow, so that arrow indicates direction of vector. Arrow, this arrow head. If you talk about this portion, that is known as head. This portion is known as tail, and this length of this arrow shows a magnitude of vector. Once again, if you see the top portion here, it is head. This is known as tail, and the length of this vector, it shows magnitude of this vector. And if we are showing this in a plane, if we are showing vector in a plane, say for example x, y, we consider here as a plane, and it is making some angle with x axis, we directly assume that this is vector A, it is having head, it is having tail, and tail makes an angle, we call it a theta with x, with respect to x. So this is a simple representation of a vector, simple representation of a vector. In terms of a symbolic form, we already discussed A bar, or you can say B arrow, C bar, and if it is not without bar, so it is a scalar quantity, or simply we can say a magnitude. So difference, when we talk about a vector, so there must be some sign, say for example A bar or A arrow, or it should be bold, or it should be a bold, so that become a vector, that is a symbol of vector. And if it is not there, if it is just A B C, that means it just show a magnitude, or it is just showing a scalar quantity. So this is the difference between vector and a scalar. Graphically, if we talk about that, so graphically vector is represented by straight line. This is a straight line, and having some magnitude, that length is presented by magnitude, and this arrowhead, it is present direction. So graphically we have to show its magnitude as well as direction, both we have to show. How? So in the case of graphical, say for example, if we want to represent a force 5 Newton acting 45 degree north of east. So these are the steps. First, take direction coordinates. First, we need to understand direction coordinates. So for example, if we drew here direction coordinate x, y, or you can say here it is mentioned NEWS, right? This is direction coordinate, come from news, or news is mentioned from this, right? So first we need to have this direction, coordinate. We need some reference to show a vector. Then we need to have a scale. We need to have a scale. Say for example, distance is given 5 Newton. So we can convert like 5 Newton is equal to 5 centimeter. We need to represent in terms of centimeter meter like that only, right? So on a graph paper, on a paper, we can draw with the use of length only. So first is we need a direction. So this is the first. Then we need to have a scale that is mentioned here. We can take as per requirement and then draw a line. Draw a line, draw a line, draw a line, right? At a given direction, at given angle theta, and with magnitude. This is the distance we need to take as a magnitude. The length is to be magnitude. So this is a direction. This is very simple method to present any vector for any kind of calculation. This is simple, very simple part. So here angle between two vectors. Angle between two vectors is to be smaller of two angles. How to consider angle between two vectors? Say for example here the drawing is given vector A and B. There are possibilities here. This is the smaller, and if we take outside of this part, so it become bigger. So when we talk about angle of vector, we can only go with this smaller vector. A bigger vector cannot be considered. A bigger part cannot be considered. So it is mentioned here angle between two vector is to be smaller of the two angles between the vectors when they are placed tail to tail, when they are placed tail to tail by displacing either of the vectors parallel to itself. So here suppose two vectors are given, say for example a vector and here it is b vector. So that has to be moved like that. Tail, this tail to tail contact should be there, and we cannot change angle. We cannot change angle of this vector. If you see the first drawing, it is already having a tail to tail connection, but in the drawing number 2, the connection is not with the tail. So what we need to do, we have to move this vector on the other direction, or we may extend this vector, and we can measure this angle as a theta, right? In the third case, if we see vector A is here, vector B is here, so there is a head and the tail connection, head and tail connection, this won't work. So in this case, we need to move vector B to the opposite side, and therefore that must be a tail connection. Of tail to tail is mandatory here. It cannot work, otherwise it cannot work. So here we need to consider a smaller angle. We understand first it is a smaller angle is to be considered, and second is there must be connection of tail to tail. If it is not, then we need to move. Let's have example number 1. So three vectors A, B and C are shown in the figure. We can see here that is a vector A makes 30 degree with x, vector B, it makes 30 degree with x in the opposite direction, and C makes 45 degree x below the x line. Fine. Find angle between A and B. So we need to find angle between vector A and vector B, then B and C, then B and C, B and C, and C and A. These three are required. So we already studied rules. What we need to do? We just need, first we need reference x, y. Then we need to put this A bar with magnitude, and that angle, same angle, 30. Then what is next? We need to put this B bar here. This is a B at angle of 30 degree opposite side, as well as the 45 last one. It is here at 45 degree. This become 45, and that is a C bar, right? And then we can directly solve it. So we can get this. So we can say distance angle between A and B, 30 plus 30, that become 60 degree. So first answer is 60 degree. Then B and C, B and C, B and C, B and C, that become 15 degree. A smaller angle we need to consider, right? By default, we used to take smaller angle, but here there is a rule. And A to C, that become 30 plus 30 plus 15, that become 75. Right? 75. So these are our answers. These are our answers, right? Seems very simple. I think you are getting some feel of physics. Great. Now, vector. Let us understand different types of vector first. Now, first it is mentioned here negative of vector means negative vector. It implies vector of same magnitude. There is no change in terms of magnitude. That's why you can see length is equal, but only direction is opposite. Right? So, for example, I'm applying some force 5 kilonewton, and there is some reaction force in the 5 minus 5 kilonewton. So both are equal and opposite. The direction, reverse direction, that is a negative vector. Just like A, when we just multiply by minus 1, it is very similar to that algebraic formula. Then is unit vector might be something new for you. See, you know that unit or unity simply just representing one. It representing one. Say for example, distance, our favorite, let's take Delhi to Bombay is equal to 1123 kilometer. But if I take unit, its unit is kilometer. Its unit is kilometer. Then it's 1 kilometer if you take. Will be precise, right? So similar case is applicable here. In the case of unit vector, where vector is having magnitude is equal to 1, or simply can say no magnitude, is having magnitude is equal to 1, or simply we can say no magnitude. That means it's a vector that should be divided by its magnitude. Its magnitude, that means mode of a. So here a cap is used to represent unit vector. A small cap is used to represent its unity or unit vector. Simply you can say a cap unit vector is equal to a bar, that is a full vector, divided by its mode. Or we can write also a bar is equal to a magnitude multiplied by its mode. Like that we can work out. Let's move. Now next is zero vector. Zero vector means what? Its magnitude is zero, right? Magnitude, there is no magnitude. That means it's a zero vector. Why it is required? You just think and answer me why zero vector is required. Tell me why 0 kilogram is required. 0 kilogram is nothing. No, wait. Similar cases here, zero vector, but it is required in terms of physics. And it is also known as null vector, right? If you have some question during your examination and it is mentioned null vector, that means it's a zero, and its direction is arbitrary. That means random. It is not having even direction, you can say, or it is having random direction. It can have x, y, z, whatever. So it is having a direction which is arbitrary, means random. Then is next is equality of vectors. When can we say vectors are equal? When can we say vectors are equal? We call say if a is equal to 2, b is equal to 2, then we can say A is equal to B, right, in terms of scalar product. But what about vector? What about vector? In case of vector, you need two things. One is magnitude should be equal, that we have seen here, and as well as it should have a similar direction. There is no change in the direction is permitted. So say for example, A is having this direction, say for example 60-degree angle with X, C is having 60-degree angle, B is also having 60-degree angle with X, and A is having 3, B is having 3, C is having 3, right? So in this case, it seems like parallel, that is okay, but two things are should be there. One is magnitude and second is direction should be same. There should be no difference in terms of magnitude and the direction. In this case, we can call vectors are equal. So here it's unit vector. It is, these are also equal. Its magnitude is also equal. And this cap is also representing direction, right? Unit vector is also representing direction. Therefore, that is talking about direction, and this values are talking about its mode or magnitude. Let's move. Next, it is a collinear vector. What did it say? Two vectors are collinear, then one can be expressed in the form of other. If two vectors are collinear, right? If two vectors are collinear, that means both are in the same similar line or maybe in the parallel. Say for example, this is having 10 in the direction, it is similar direction. Say for example, A cap, and it is having 1 direction is same, A cap. So both can be represented just directly. Say for example, it is A and that is B. So you can say A is equal to vector A is equal to lambda, means 10 times this P vector, right? So here in case of collinear, line of action of all the vectors act along the same direction, it is mentioned. Line of action, a bigger vector or a smaller vector, whatever, all are in the same direction, and here there is a magnitude is only difference, right? So we can have multiplication in terms of constant, and that vector just become this many times. Otherwise, its direction is similar, and it is in the same line. Collinear, it is having on the same line. So I think you must have understood with what is collinear. Sometimes a like word is used when the direction is similar. Next is co-initial or concurrent. Why do co-initial? From the name in itself, you can judge, but concurrent is also a word that is used for the similar case. What it says that the line of action of all the forces in a system passes through a single point. If one force it is here, or you can say one vector it is here, another vector is moving in this direction. In the forces, or you can say vector, we can write here, right? If all are passes through a single point, that means they are co-initial, or you can say concurrent. Or you can have another drawing, all are initiating with one single point, all are initiating with a one single point and going in this direction, another is direction, right? So we can say them as a concurrent or co-initial vector. Second is coplanar. Coplanar means all vectors are in a single plane. Say for example, this is my xy plane, this is my xy plane, this is my xy plane, and all are on the plane, xy plane. All the vectors are in a single plane. All the vectors are in a single plane that are known as coplanar. We will see examples for that also. You just understand as of now the simple meaning of that part. So, not if the frame of reference is translated. That is a specific not for the every part. Suppose initially S and this is B vector. If this entire vector S and B is shifted to at some angle, right? S and B are having the similar angle, whatever it is having initially. But if it is moved to some other angle, its property remain constant. There is no change in the terms of property. If the entire every all the vectors are changed, then it is not having change in terms of vector properties. Right? But all the vectors has to be changed, right? Otherwise, there will be change in terms of magnitude. So we will understand this all in the very detail by taking examples. It is the best method to take it. Now let us understand system of vector by taking various examples. So first we understand collinear. So line of action of all the vectors are in the same line. And the example is given here, tug of war. I think you must have played a tug of war where a rope, right, and on the both the side group of people, right, they pull on the opposite side and right. So all the forces, all the hands are on this tug of war are having in the similar direction, on the similar direction, single direction, in the direction of rope, in the direction of rope. So this party, this side A and this side B, right? So A is apple side is all are in the same direction, all are in the same direction, and the B side are having all on the opposite direction. So all the line of action take place in a single line. Line of action take place in a single line. So that become collinear. That means from the word also we understand, right? All forces are in a single direction. Second is coplanar. All the vectors are parallel to each other. So what is mentioned? One is word is coplanar and second word is mentioned parallel. Coplanar, that means, say for example, if it draw x and y plane, so all are should be in the same plane. And second is parallel, that means angle should be equal, right? This angle theta for all the vectors must be equal. For example, force is acting on a beam, it is just a horizontal bar, and this is a bench. Simple, consider we stand here on this bench, about three people are there. So all are on a single plane and all are parallel. Vertical forces are there and all are in a parallel path. Simple to understood. The next is coplanar. The first word is coplanar. That means what? Are in a single plane, x and y. Second is parallel. So we understand, right, what angles must be equal among all of this vector, and the like. Another word is used, like. Like, that means see the arrow direction. Arrow direction must be same. Arrow direction must be same. Right? Magnitude can be different, but arrow direction must be same. So three things are mentioned. One is coplanar, means single plane, xy. Like means all the direction should be in the same side, similar side. And the parallel, we know that angle should be equal for all. Angle should be equal for all. So example, weight of a stationary train on a rail. Say for example, this is a rail track and there is a track. So all are having single direction, downward direction, all are having load downward direction, and all are parallel and all are in single plane. Comment me more examples on all of this. The next is coplanar. Again mention coplanar means single plane xy. What about concurrent? Concurrent means pointing. All the forces are pointing, or you can say passing through a single point. All must passes through a single point. Right. So line of action of all vector passes through a single point, and forces on a road resting against wall. Forces on a road, say for example, this is a wall and there is some kind of wall. So this is somewhat road. It is resting. So whatever forces are reaction forces may be there, or downward forces may be there, friction forces may be there, whatever, they all are pointing at the similar place, similar place. You will be solving so many examples on it. Don't worry. Then next is coplanar non-concurrent. Tell me what about coplanar? Coplanar we understand XY plane, and non-concurrent means all of are not all of are not pointing at a single point. All of are not meeting at a single point. Let's for example, the weight of vehicle on a thin bridge, weight of vehicle on a thin bridge, or you can take any other weight, any other consideration when the detail we are considering. So it is having non-concurrent means all the forces are not meeting at the similar point. Say for example, this is a bridge. One vehicle is here, another vehicle may be having some angle, some kind of load. It is having some movement. So all are not meeting. Any of them are not meeting. Non-coplanar, that means not about 2D, but this is going to be a 3D, not in a single plane. That means loads are not just associated with X and Y, but it is also with Z. Again, non-coplanar X, Y not sufficient, it is with the Z also. And parallel, that we understand, right? It is parallel, that we understand. Tree. Example of weight, tree. Then weight of benches in a classroom. There are benches on a classroom 3D drawing. One bench is located here, second located here, three. Right? So there are three-dimensional parts are there, and you can find plenty of other examples also. Non-co-planar, that means it's a 3D, and concurrent, that means meeting at the single point. Tripod. Yeah, we used to record with the use of this tripod, and we mount camera on it. The tripod, all the weights see here are in the three dimension. One force is here, second force, third force, and the fourth force. All are meeting at a single point. So that become non-coplanar. That means it's a 3D and concurrent, meeting at a single point. Then last is non-coplanar and non-concurrent. Non-coplanar and non-concurrent. Non-coplanar, that means 3D, and non-concurrent, that means not meeting at a single point. And action you can take, there are large number of examples you can find. Forces acting on a moving buses may be there. One force may be on the ground, vertical forces, friction forces can be there, wind forces can be there. There are lots of possible, right? So what I suggest you that you do not learn the entire chapter at one go. You break the chapter into 4-5 session. Every day you just take small portion of this part, and then only it is going to be understood by you, right? You cannot learn the entire chapter in one go. Remember that. So next is vector multiplication or division by a scalar. So multiplication of a vector by a scalar quantity, say for example, a bar is multiplied by some lambda, it's just a scalar. So it give me another vector, b bar is equal to lambda times a bar. This is very simple. So ultimately, a new vector, that means lambda, if it is a positive value, so magnitude, it becomes just lambda time a. If lambda is a positive, that means simple, it's a magnitude, just it affect the magnitude, nothing else. Scalar just affect the magnitude. So it becomes lambda times a bar in the similar direction. Directions are not changed with scalar quantity. And if it is negative value, lambda, then lambda become negative. lambda become negative. Or you can consider, or see, remember what, or you can consider opposite direction, or you can consider opposite direction. Both cannot be considered. Either you consider lambda as a negative or consider direction as opposite. Otherwise, this minus sign automatically specify direction is opposite. Now, division of a vector by a scalar. So, similar cases here, a multiplied by 1 by m, that is a division. M is maybe positive or negative, or it should be non-zero. It should be non-zero. So, it just divide vector m, vector a, just it divide 1 by m times. So, in the case of multiplication or division by a scalar, it just magnify its value. Magnify value. And here the resultant, if it was initially a bar vector and multiply by some lambda, b become lambda a bar. So in this case, both become collinear. In the case, both become collinear. Both become collinear. Right? These small things you need to remember, right? This kind of questions maybe there in the exam. And by understanding, deeper understanding, you can solve it. Let us solve an example. See, solution of example is the case. Example is given here of physical quantity mass 3 kilogram is multiplied by a vector a, that is from acceleration, such that force is equal to mass multiplied by acceleration. Find the magnitude and direction of f if a bar is equal to 3 meter per second square eastward, and second case a bar is equal to minus 4 meter per second square. Now to solve this kind of questions, you must know the direction. And this is, you just remember by using this line NEW as views. Knowledge of direction is important to solve this kind of problem, right? You just understand that NEW as, you just make NEW as, and start with NEW as. You just make this kind of views. And so the question is like that, a bar is towards eastward, a bar is going towards eastward. So this is a bar towards east, and that is the value of a bar. You can take 3 as a magnitude. And we know the equation is equal to F is equal to mass multiplied by acceleration. Mass is a scalar quantity, A is the acceleration, is a vector quantity. And it ultimately gives us scalar multiplied by vector. We understand that it gives us a vector quantity. And that's why this knowledge is required. So 3 kilogram put here, 3 kilogram, and answer is 3 the direction of east, in the direction of east. So answer is 9, and the direction remains same. There is no change in the same direction, so direction will be same. Force is applied in this direction and the answer is also in the same direction. The next question, it is A is equal to minus 4 meter per second square. A bar, it is here now minus, so direction is negative. Put the similar value here. Answer is 12. Northward, if you talk about northward direction, this is the north direction, is upward direction. But our answer is negative. So here we need a negative vector. And to just show a negative vector, we just need to multiply by minus 1. It gives us plus 12. And the opposite direction is south. Opposite direction is south, right? So here negative vector is useful. Right? We already learned what is meaning of negative vector.